Hello students, hope you all are doing well. In our previous class we have discussed about electric field due to a charged ring. Today we will discuss about lines of force. Now we were discussing about electric field and everything. Now won't it be easy like if we can visualize the electric field? Now, to visualize the electric field, we are using the concept of lines of force. That means we will use lines, simple lines, to visualize the electric field. Now, let's see what are the importance or what is the necessary for the what are the importance rather of the electric field lines. An electric line of force is the imaginary smooth curve. Now it's imaginary because it doesn't really exist. It's for our imagination basically, so that it's we are able to imagine electric field in a better way. Smooth curve drawn in an electric field along which a free isolated positive charge moves. The tangent drawn at any point on the electric field gives the direction of the force acting on a positive charge placed at that point. Now let's see what does it mean. So basically now we have come to know that electric field lines are basically lines of force, simple lines which helps us to visualize how the electric field will be. Now these if we leave any isolated free charge, then what will happen, that charge will move along the line of the electric field. Now, at any point of the electric field, the direction of the electric field can be given by the tangent drawn at that point of the field. Now, suppose this is the electric field line and there is a charge. We have kept a charge over here, so the charge will move along this line. Okay, now we need to find in which direction the electric field is. So if we take a point P and we want to know in which direction the electric field is in at point P, so we simply have to draw a tangent to that line in the direction of the motion of the charge, not opposite direction of the motion of the charge. Suppose the charge is moving in this direction, so the tangent will be in this direction. Now tangent can be in this direction also, right? Tangent can be in opposite direction also, but we will not consider this. We will consider on the tangent in the direction of the motion of the charge. Now if the charge comes in this point, so we want to know the electric field, so simply we have to draw the tangent in this point. So we will come to know that field at point R is ER and this is the direction. Now we will learn about the patterns of electric field. By just simply drawing lines we can describe an electric field. Let's see how we can do that. So if the lines are unequally spaced but parallel to each other, then we can say that magnitude of the electric field is not constant. Next, if the spacing between the lines are equal but the lines are not parallel to each other, and the lines are equal and they are parallel but they are not straight, that means we can say that direction is not constant. That means the direction of the electric field also keeps on changing. Now if both the spacing and also the lines are curved, that means both magnitude and direction is not constant. Now let's say in case number 4, here the lines are parallel to each other, the lines are straight, and also the spacing between each line is same or equal. So here we can tell that both magnitude and direction is constant. Next, move on to our next. Now if we have any positive charge, so electric field lines leave from a positive charge, they originate from a positive charge, so the arrows are given outward or they diverge from a positive charge. And in case of negative charge, electric field lines converge in the negative charge or they terminate in the negative charge. Now if we have a dipole that is a positive and a negative charge, so here we will draw the electric field lines and the directions are very important. The field lines will move away from the positive charge. See, the field lines are moving away from the positive charge and they are entering into the negative charge. Okay, here in this case number 8, we will see we have taken two equal charges. that means two like charges. Here we have taken two positive charges, so the electric field lines will diverge from the positive charges. Now in this point there will be a place where there is no electric field lines, and this point is called the neutral point. In the neutral point, if we keep a test charge, it will not experience any force. Now suppose we have a line charge, a line in which we have given a positive charge. So what happens? We will get parallel electric field lines moving away from the line. Since these are positive charges, so the direction of arrows will be away from the lines. So in our next class, we will discuss about the properties of electric field lines. Thank you.